Assalamualaikum and hi. In today's video, we are going to talk about gradient of tangent, equation of tangent, and equation of normals. Okay. Suppose that we climb a mountain or a hill that looks something like this. This is your mountain or hill maybe. Okay. And you climb the mountain and you stop at this point. I name this as point P such that the coordinate is x1, y1. So you climb that hill and stop at point P. So what is the steepness of that point? And what is the gradient of that point? How steep your position is? Okay. The thing is, there is a relationship between the gradient of the curve at point P and the gradient of the tangent at point P. We can say that the gradient of the curve is just equals to the gradient of the tangent. And in this case, at point P. So this is your tangent. We can say that the gradient of the curve is just equals to the gradient of the tangent at point P. So whenever you want to know the gradient on any points on the curve, the gradient of any point on the curve, you just need to find the gradient of the tangent at that point. Okay. So in other words, I would say that gradient of the curve at point P is just equals to gradient of the tangent at point P, which is just equals to the value of the first derivative, which is dy over dx, when x equals to 1, when at point P, which is just equals to f prime x at point P. Okay, so this relationship is very important. If you want to find the gradient of the curve at point P at any point, this is just equals to gradient of the tangent at point P, which is just equals to the value of dy over dx at point P, or we can say it's just equals to the value of f prime x at point P. In this case, we can say that the value of f prime x1, since point P is just x1 there. Okay, all right. Let's look at the example. Okay, find the gradient of the curve y equals to x squared plus 3x plus 5 at point -1, 9. So we want to find the gradient of the curve at point -1, 9. So what you need to do is just, we know that gradient of curve is just equals to gradient of tangent, which is just equals to dy over dx. So dy over dx is just the gradient function. Okay, let me point out. We can say that dy over dx is just the gradient function. Okay. So in this case, we have this function, okay, y equals to x squared plus 3x plus 5. Therefore, dy over dx, which is the gradient function, is just 2x plus 3. And we know that this is the gradient function. We want to find the gradient of the curve at point x equals to -1, y equals to 9. So at x equals to -1, dy over dx is just equals to 2 times -1 plus 3, which is just equals to 1. So we can say that the gradient at point -1, 9 is just 1. Okay. If we draw this graph, I think the graph will look something like that probably. Okay. Or maybe something like that. Okay. So this is the point -1, 9. So we want to find the gradient of this point. So say this is y equals to x squared plus 3x plus 5. So we want to find the gradient of this point. This is just equals to the gradient of the tangent that passes through that point. So m of this tangent just equals to 1. Okay, so the steepness of that point is just equals to 1. So positive going up, negative going down. Okay, let's have a look at one more example. Find the gradient of the curve of y equals to 3x squared over 1 minus 4x squared when y equals to -1. The thing is, they give you y equals to -1. So first, you need to find the corresponding value of x. So when y equals to -1, so we will have -1 equals to 3x squared over 1 minus 4x squared. Okay, so bring that to the left hand side. We will get -1 plus 4x squared equals to 3x squared. So x squared equals to 1. So we have x equals to plus minus 1 in the sense that we have two coordinates here, 1, -1, and also -1, -1. Okay, we have two values of x. That is the first step. The second step is we find the gradient function. Which is just dy over dx. Okay, so in this case we need to use the quotient rule since we have division. Okay, so we let our this is our u and this is our v. Okay, so u is equals to 3x squared, means that u prime is just equals to 6x. V is equals to 1 minus 4x squared. Okay, so V prime is equals to negative 8x. Okay, which means that dy over dx is equals to vu prime minus uv prime over v squared by quotient rule. So which is just equals to our v is 1 minus 4x squared, u prime is 6x, minus u is 3x squared, v prime is just negative 8x over with v squared. So our v is 1 minus 4x squared. Okay. We already have our gradient function. So when x is equals to 1, and also we have the case when x is equals to negative 1. So when x equals to 1, dy over dx, which is the gradient function, is just equals to, we just substitute the value into the equation. So we can have 1 minus 4, 1 squared multiply with 6 times 1 minus 3, 1 squared multiply with negative 8 times with 1 over with 1 minus 4 times 1 to the power of 2. And when you press your calculator, you will get 2 over 3. Similar to this one. So when x equals to negative 1, dy over dx just equals to this whole thing I just need to substitute the value of x with negative 1. So it becomes negative 1 squared. This is negative 1. Negative 1 squared. Negative 1. Negative 1. So you press your calculator, you will get negative 2 over 3. Okay. Okay, now we are going to talk about the equation of tangent. Equation of tangent at a point on the curve. Okay. So suppose that you have a curve, right? Say any curve, and you have a tangent that hits one point. This is tangent. And you want to know the equation of this tangent, okay? And we know that basically tangent is just a straight line. So if you want to find equation of a straight line, we can use y minus y1 times equals to mx minus x1. This is just the basic equation for straight line. Okay. Before that, say that the tangent hits the curve at this point. I name it as x1, y1. Okay. And another point is that gradient of tangent, we've talked about this before early in this class. Gradient of tangent is just equals to the first derivative. Okay, means that gradient of tangent at x1, y1 is just equals to the value of dy over dx at x1, y1. Okay, gradient of tangent can be represented by the symbol mt. Okay, so when I write mt, or when you see mt, this means gradient of tangent. So if you want to find equation of tangent, we can use the formula y minus y1 equals to mx minus x1. And we know that this is just a general equation for a straight line. But remember, the gradient here is gradient of the tangent. Okay. And that is just dy over dx. Okay, remember, gradient of the tangent is just dy over dx at x1, y1. This is just dy over dx. Okay, let's have a look at example. Find the equation of tangent to the curve y equals to 2x squared minus 3x plus 1 at point 2, 3. Okay. We know that equation of tangent can be found by using the formula y minus y1 equals to mt x minus x1. Okay. At this point here is 2, 3. So we know that this is our x1, this is our y1. Okay. So we have no problem with substituting x1 and y1 because they have given us the point. So y minus 3 is just equals to mt x minus 2. The thing is, what is mt? And we know that mt is just equals to dy over dx at x equals to 2. So we need to find the dy over dx. Dy over dx is just equals to Okay, differentiate that function. We will have 4x minus 3 at x equals to 2, dy over dx is just equals to 4 times 2 minus 3, which is 8 minus 3, we'll get 5, is that mt is equals to 5. So substitute that value to that equation. So we will get y minus 3 equals to 5x minus 2. So what you need to do here is just expand and simplify so that we will get it in the general form of the straight line. So y minus 3 is just equals to 5x minus 10. So y equals to 5x minus 10 plus 3. So y equals to 5x minus 7. Okay, so basically this is the equation of the tangent. Okay, if I want to illustrate this, possibly your curve, this is a smile curve. Okay, so because the coefficient of x squared is positive, then we should have a smile curve, and we have this as 2x squared minus 3x plus 1. Okay, this is our curve. Right. Suppose that this is your point 2, 3. So the tangent that passes this point 2, 3 is just a straight line, and we know this is our tangent. Okay, this is our tangent, and the equation of this tangent is that one. So the equation of tangent is just y equals to 5x minus 7. Okay. Now let's have a look at one more example. Find the equation of the tangent to the curve y equals to x plus 2 over x at x equals to negative 1. Okay, we want to find the equation of tangent. So equation of tangent, the formula is y minus y1 equals to mt x minus x1. We already have our x1. Okay, we already have our x1 is given negative 1. But so now we need to find our y1. How do you find your y1? It's just insert the value of x into this equation here. Okay, because that point lies on the curve as well. So it doesn't really matter how the curve looks like, but you can always find the corresponding value of y given any x. Okay, so when x equals to negative 1, y is just equals to negative 1 plus with 2 over negative 1, you should get negative 3. Okay, so our corresponding value of y is negative 3. So means that we can insert that point into this equation. So we will have y minus y1 is negative 3, so negative 3 equals to mt x minus with negative 1. Our x1 is negative 1. So minus minus will get plus. Y plus 3 equals to mt x plus 1. Now we want to find our gradient m. Okay, To find our gradient, mt is just equals to dy over dx at x equals to -1. Since we have y equals to x plus 2 over x, I can rewrite this so that it becomes 2x to the power of -1. Okay. So dy over dx is just equals to 1 plus with -1 times with 2 times with x, power of -1 minus 1. So 1 minus 2x to the power of -2. Okay, which is just equals to 1 minus 2 over x squared. When x equals to -1, you will have dy over dx equals to 1 minus 2 over -1 squared. Press your calculator, you will get -1. So our mt is just equals to -1. So insert into the main formula. So -1, x plus 1, expand -x minus 1. So y equals to -x minus 1 minus 3. So y equals to -x minus 4. So this is our equation of tangent. Okay, now we are going to have a look on the equation of normal first. Let's see what does normal means. Suppose you have a curve, okay, and you have a point P, x1, y1. The point can be any point along the curve. I pick this point here, and we have a tangent, which is just a straight line that passes through that point. And for every tangent, there will be a perpendicular straight line that passes through the same point. So between the straight line and the tangent is 90 degrees. Okay, so this straight line is known as the normal. Therefore, by definition, we can say that the normal to the curve y equals to f of x. Say this curve is y equals to a function of x at point P x1 y1 is just equals to the straight line that passes through point P x1 y1 and is perpendicular to tangent at point P. Okay, so the curve, tangent, normal, such that the tangent and normal is perpendicular to each other. It has to be 90 degrees. Okay. If you want to find the equation of normal, and obviously normal is also a straight line, so what we need to do is we use the formula for the equation of the straight line, which is y minus y1 equals to m x minus x1, such that our m is not gradient of tangent, instead it's gradient of normal. Such that the relationship between gradient of tangent and normal is, since both are perpendicular to each other, gradient of tangent times with gradient of normal is equals to -1. Therefore, gradient of normal is just equals to -1 divided by the gradient of tangent. So that is the basic equation of normal. Let's have a look at example. Find the equation of the normal to the curve y equals to x to the power of 3 plus 2x squared plus x plus 3. And we know that the formula for equation of normal is just y minus y1 equals to mn x minus x1. And we have the point 17, this is x1, this is y1. Okay. Therefore, we have y minus our y1 is 7. Mn, we don't know yet. X minus x1 is just 1. Now, our challenge is to find Mn. To find Mn, we must first find Mt, gradient of the tangent. Okay. Mt is just dy over dx at x equals to 1. So dy over dx is just 3x squared plus 4x plus 1. At x equals to 1, it becomes 3 times 1 squared plus 4 times 1 plus 1. You should get 8. Okay. And the relationship between Mn and Mt is that Mn times with Mt is equals to -1. This because Mn and Mt, because normal and gradient tangent are perpendicular to each other. So when you have two perpendicular straight line, the gradient of one line times the gradient of the other line, you will get -1. Therefore, Mn is just equals to 1 over Mt, which is just equals to -1 over 8. So now we have Mn equals to -1 over 8. So y minus 7 equals to negative 1 over 8 x minus 1. Now we rearrange so that we could get a general form y equals to mx plus c. So y minus 7 equals to negative 1 over 8x plus 1 over 8. So you can multiply everything with probably move negative 7 to the right hand side. So y equals to negative 1 over 8x plus 1 over 8 plus 8. So this one here you will get 1 equals to negative 1 over 8x plus 57 over 8. Alternatively, you can also rewrite this equation by multiplying everything with 8. You should get 8y equals to negative x plus 57. Now let's have a look at the next example. Find the equation of the normal to the curve which is parallel to the line 2y minus x minus 3 equals to 0. You want to find the equation of the normal. Okay, so basically the equation of the normal is y equation of normal is just y minus y1 equals to mn x minus x1. The problem is we do not have our y1, we do not have our x1, and we do not know our gradient. But we can actually find these values based on the information given. Okay, before we start, let's have a look at the basic idea of the graph. Suppose that we have this curve. This curve is a sad graph because the coefficient of x squared is negative 1. Therefore, probably the curve looks like this. So this is just y equals to 3 plus 2x minus x squared. And suppose I pick this point as my x1, y1. And there is a tangent that passes through that point, and obviously there will be a normal. So normal line. So this is our normal, and this will be our tangent. And from the equation, it is said that the normal is parallel to this line. Means that there exists another line which is probably not on the curve, or probably it will be on the curve, we don't know, but there's another line which is parallel to the normal, such that the equation of this straight line is 2y minus x minus 3 equals to 0. And if you rearrange that into a normal form, general form, you should get 2y equals to x plus 3. Therefore, y equals to 1 over 2x plus 3 over 2. And since the normal is is parallel to the straight line here, So we can see that both have the same gradient. Therefore, I would say that we have the information that mn is just equals to 1 over 2. Since this is, from the general formula, y equals to mx plus c. Since both the straight line and the normal is parallel, then both have the same gradient. Therefore, the gradient of the normal is just 1 over 2. Hence, we can see that we have y minus y1 equals to 1 over 2 x minus x1. And now we need to find our x1 and y1. So how do we find that? Given given the information we know that mn times with mt is always equals to -1. That is the relationship between gradient of tangent and gradient of normal. So mt is just equals to -1 divided by mn, which is just equals to -1 divided by mn. Our mn is 1 over 2. Therefore, -1 times with 2 over 1. We get the gradient as -2. This is the value of mt. And we know that gradient of the tangent is just equals to dy over dx. So which means that -2 is just equals to dy over dx. Differentiate that curve. So our dy over dx should be okay, we have y equals to -x squared plus 2x plus 3. So dy over dx equals to -2x plus 2. Okay. So which means that this is just equal to -2x plus 2. Let me double check. Alright. Which means that -2x equals to -2 minus 2. So x is equals to -4. Move that one. Divided by -2. So we have x equals to 2. Right? So when we have x equals to 2, now we can insert that y minus y1 equals to 1 over 2 x minus 2. Now we need to find the y1. How do you find y1? It's just you take x2, insert into the formula of the curve, because obviously for each value of x we will have the corresponding value of y. So y equals to 3 plus 2 times 2 minus 2 squared. You should get by calculator 3. The value should be 3. Means that in this equation, y minus 3 equals to 1 over 2 x minus 2. So expand that, y minus 1 over 2x minus 2 over 2 plus 3. So y is equals to 1 over 2x plus 2. So this is your equation of normal. Okay. I think that's it for this video. We have covered what does it mean by gradient of the curve, gradient of tangent, and we also have covered the equation of tangent and also the equation of normal. That's all for today. Thank you.